Hey, what's up, you guys? Coach Robbins here. I hate that we're having to do this like this on video, man. I wish we could still be here in class together, But when stuff happens, you gotta do what you gotta do. This is going to be our seventh grade math video. We're gonna do 7G1. We're gonna talk about skill factors. All right. So the first thing we're gonna do is talk about some prerequisite information. So our first word is ratio. It's a vocab word. It's just a comparison of two numbers. So if you see, we got two examples. We've got 1 to 2, which is how you would say this. It's got a colon, but still 1 to 2. And then you've got one that looks like a fraction, but you still also say it as 1 to 2. The next thing is a proportion. We've done proportions a lot this year, just making sure we got some prerequisite information again. So for a proportion, the definition would be an equation stating that two ratios are equal. Okay, so we just talked about a ratio being, you can write it either way, but for proportions, we're going to do them as, well, they look like fractions. Okay, so for my example, it says the proportion is 1 to 2 is equal to 2 to 4. All right, so now we're going to talk about some ways that you can prove that proportions are true, or that two things are proportionate. So here we got the same two ratios. We got 1 to 2 and 2 to 4. So in this one, we are just going to take them and divide them like they're fractions. So we're going to do top divided by bottom. All right, and if you do that with 1/2, you're going to get 0.5. Take your calculator and just type the first one divided by the second one. You do 1 divided by 2, you get 0.5. Do the same thing for the second one, which will be 2/4. You'll get 2 divided by 4 equals 0.5. All right, moving on. All right, here's another way, and I worked this out on a piece of paper, and I hope you can see it pretty good. So we started with the same proportion. 1 to 2 is equals 2 to 4. Okay, and on this we're going to do cross multiplying. All right, so to cross multiply, if you look at the picture on the right, you're gonna take the top left, all right, and it goes with the bottom right. So in this one, I've circled them. It's gonna be 1 and 4, and then you're gonna take the bottom left and go with the top right, and it's gonna be 2 and 2. So we're doing cross multiplying. So as I circle those things, I'm gonna take whatever circle together and multiply them. So I'm gonna go 1 and 4 equals 4. Put that on the top, and then we're gonna do 2 times 2. And that's also 4, and that's going to go on the bottom. Now, when you get to that, if those numbers are the same, all right, and then you do 4 divided by 4, you get 1. All right, that 1 right there is what tells you that those two ratios are proportional, okay? And that's what we're working on here with proportions. That's just two things that are pretty important to make sure that we understand before we get into the actual stuff that we're learning here in 7G1. All right, and then as we go to the next slide, all right, right here on scale drawings, this is the actual 7G1 stuff that we're talking about on scale drawings, and we just started right here with the definition. Scale drawing is a diagram or map or model of an object that is too large or too small to draw, and the dimensions are proportional to the actual dimensions or distances of the real life example. Okay, and some examples there are maps, blueprints, and floor models. And if you remember when we talked about this in class, we talked about how if we're going to build a house, we don't get a piece of paper that's the same size as the house and draw the whole house out on it. We take this scale drawing and we set it proportional to where we can draw it on a piece of paper as to how big the actual house is. So for scale drawings, one thing that I know helps, I mean, a lot of times y'all have questions, how does this apply to real life? How can I use this for the rest of my life? Well, anytime you go in a building or your house or a garage or shop or something, anything that's basically anything that's bigger than something you would draw on a piece of paper, this is what they use to design those. If you've ever built a house, or if you know someone who's built a house, their blueprints, you can probably still find those. I know whenever we were in class, Mr. Matthews let me borrow his blueprints, and I kind of showed those to you guys. So those are just some real life examples, ways you can take scale drawings in the math class and apply them into real life. So the next vocab word for this is going to be scale. A scale drawing is the ratio of the drawing lengths or model to its corresponding actual lengths. Okay. So the scale is the thing you actually can draw. So the blueprint is the actual scale. All right. And then the scale, you take the distance on the blueprint, all right, and you take that and the actual distance that the house is, make that into your scale. For example, just a few examples, like, all right, so if you got your house and on your blueprint you got 1 inch of the house equals 1 foot in real life. All right, so every inch of the drawing is 1 foot in real life. Okay. All right, so from there, we're going to move over to this notes, and then this just has the stuff that we just talked about: scale drawing definition, scale definition. All right, and then we're going to slide on down right here. And all right, here's an example of a scale. So this is going to be a pool right here. So you can't draw the actual pool on a piece of paper, so they take their scale drawing, all right, and their scale says that every 1/4 inch on this equals 2 feet of real life pool. So every 1/4 inch in this drawing is equal to 2 feet of the actual pool. Okay. So if we're scrolling down right here, here is the scale factor. Okay. So scale factor is the ratio of two corresponding sides of two geometrical shapes. So the scale factor would be, say you have your scale already, and then we're going to compare the scale to the actual drawing. So here it says, write the scale as a ratio showing the scale length to the actual length. Okay, so scale length to actual length. All right, and a ratio, and in this ratio right here, we're going to use the one from the beginning of the slides that had like 1:2. All right, next, change the length to the same unit of measurement and then drop it. Usually convert the bigger unit to the smaller unit and then simplify. Okay. All right, so there's one way you can do it. You can change them to the same thing. Another way that we're going to find the scale factor is using the proportions that we talked about in the prerequisite information. So here is here's a few right here, finding the scale factor. All right, we're going to go down to Jacob. All right, right here. Jacob has made a scale drawing of his yard. The scale of the drawing is 1 centimeter equals 0.5 meters. Okay, so now I have that here. All right, and we're just going to kind of work this out together. Okay, so here, if you see this, it says Jacob's scale factor, and he's got 1 centimeter is 0.5 meters. Okay, so the question was, the length of the patio is 4.5 centimeters. Okay, so I'll set that in a ratio in the fraction form, and we're about to set it up in a proportion. So I'm going to take that, and it says, notice I use my measurements. I put centimeters here, meters on the bottom. All right, so here we're going to take whatever the centimeters is that we have. Okay, so it gives us 4.5 centimeters. So we're going to take 4.5 and place it here. Okay. And then we're looking for the actual distance, which is going to be the meters, and we don't have that. So when we don't have something, we're going to plug in an X like this. Okay. Now we're going to do our cross product. Same thing as before. We're going to take this bottom left with the top right, top left with the bottom right. Okay. Now we're going to multiply them. So these two have the numbers. So we're going to do 0.5 times 4.5. All right. So when we do that, we're going to get 0.5 times 4.5 equals 2.25 over. All right. And then here, if you remember how we did it, we did these two times each other divided by the one that's by itself. So divided by 1 centimeter. And that's going to equal 2.25 meters. All right. So that's going to be your answer to that question right there. All right. Now, as we move on, if you look over, here's kind of the questions that you've got in your thing. It's going to be like number 66. Okay. So that question right there that we just did is going to be like number 1. Now, number 2 is going to be kind of the same. Okay. It's got, it gives you a scale, and then you take that and use the actual measurements that it gives you up there, 39 feet by 112 feet. And it gives you one of the distances with the scale drawing, and you have to work out with the proportion. All right. Now, on the third one, explain the relationship between your answer to question 2 and the scale of the drawing. Okay. So if we go back here, explain your relation of the drawing, which was 4.5, and the actual one, which is 2.25. Okay. So explain the relation of these two. Okay. So all you're going to do is take your scale factor, which is 1 and 0.5. So you divide 0.5 divided by 1, it's going to give you 0.5. So if you take the number they gave you, 4.5, times 0.5, you'll get 2.25. So the difference is the the actual distance is 0.5 times the drawing. Okay, so we go back to your question that you have, and we keep going down to number 4. All right. Now this one right here is going to be a little bit different because you're going to have to actually draw something. So this is taking what we've learned so far and then adding it into the real life part of you actually helping draw the blueprint. So on there you have a polygon, and then we're going to talk about the one that I have here, an example problem. So we'll go back real quick and just look at the question. Oops, my bad. So here you've got, it gives you a landscape design, a blueprint of a garden. All right, so here on mine we've got a rectangle, and it gives you the scale. It gives you the scale for the one that they have already drawn, and then the scale for the one that they want you to draw. All right, so this one's going to be a lot like that. So if we come back and look at this one, so here's your scale for this one. So each block, we're going to represent that as a centimeter. So 1 centimeter equals 4 feet if we actually had drawn this rectangle garden. Okay, and then here we got 1 centimeter equals 2 feet. So we've changed the scale from 1 centimeter equals 4 feet to 1 centimeter equals 2 feet. Okay, so we have to figure these actual distance out. Okay, that's going to be our first thing, is find the dimensions. So if we count this is going to be 1, 2, 3, 4, 5, 6. So it's going to be a 6 by 1, 2, 3, 4. 6 by 4 rectangular garden here. Now over here, we're going to have to figure out what relation does the 4 foot and the 6 have to make this rectangle. That way we can draw ours. So if we go here, we go 1 centimeter over 4 feet, just like we did a while ago, make our proportion. Equals 1 centimeter equals 4 foot equals 6 centimeters over how many feet? Okay, so then we're going to cross multiply. We're going to get 4 times 6. 4 times 6 gives us 24 divided by 1. Okay, divided by 1 because that's the one that's with the x here. Okay, 24 divided by 1, and that's going to give us 24 feet. Okay, sorry, 24 feet. So the actual distance of this garden will be 24 feet long. Now, if you go over here to the new scale, we got to figure out what's the difference in this scale and this scale. Okay, so this one is 4 feet. This one's 2 feet. So if we figure that out in our head here, 4 is twice as many as 2, or 2 is half of 4, right? So I'm going to take however long this distance is and divide it by 2 to make it equal for this one. All right, so we've got 6 there. So I'm going to start. You pick your square here, any square, start right there. All right, so from here I go right 6. So I'm going to half that and go 3. So 1, 2, 3. Boom, right there. And then from here I'm going down 4. So I'm going 1, 2, 3, 4. Half of that is going to be 2. So I'm going 2, and then you just fill in the rest of the rectangle. Okay. So now we know this is 3 and this is 2. Okay. So if this went from 6 centimeters on our scale drawing to 24 feet in real life, let's see what this one does. All right. So it's going to be the same thing. We're going to set up as a proportion. 1 centimeter over 2 feet equals 3 centimeters over X feet, because that's what we're trying to figure out, is how many feet is this garden going to be in real life. So we cross multiply 2 and 3 gives us 6 over 1, which equals 6 feet. Okay. So if we go back and look here, all right, this is how your question is. So it starts as 10 feet and goes to 5 feet. So it's going to be just like this one that I worked, except you're going to have to redraw it right here. All right, then we go down. How did the new scale change the length of each side of the figure in the blueprint? Okay, so if we're thinking about the blueprint here, we are going to look at the scale. So on this one, how did the new scale change the distance? Okay, so if you look at the top or the length here, it goes from 6 to 3, right? So you could say it subtracted 3. But then if you look at this one, it goes from 4 to 2. Does that subtract 3? No, right? So the same way that we found that this is 3 and this is 4 is how we're going to do this. We go from 4 feet to 2 real feet. Okay? So how did we get from 6 to 3? We took half of it. So we go back to our question. Says, how did the new scale change the length of each side of the figure on the blueprint? Okay, so if we're going from 6 to 3, we took half. So that means our answer to our question here, how did the new scale change the length of each side of the figure in the blueprint? On this one right here, the answer to that would be the new scale halved or took half of the original scale. Okay. So here you can see this. The new scale, half of the original scale. Okay. So that's going to be all the questions that you have there on yours. I hope that this video helped you guys. I hope that you can take it and as you're doing your packets or whatever, use this to help you. Or if you need some, just wanted to look back and try to remember things about scale factor, because like I said, this is actually one of the most life applicable things that we've done this year is using scale factor, as far as you guys being able to see how you can use this in real life. So if you've done some quarantine projects, like we've cleaned a lot of stuff at our house. made a swing. So I mean, if you're making something at your house, if you're making a tree house or something like that, making a shed, use your scale factor. Go out there and whoever's making it, tell them, hey, look, back up, I got this. I know how to do this stuff, man. We done this in class. Uh, so I hope you guys can use this video, to help you with your packet or help you with your projects if you're doing any. If there's any questions, you guys can email me or hit me on Remind. Hope you guys have a good summer. I'll see you.